Okay, let's get started. Thanks for waiting, everybody. The keynotes got going a little bit late, so I was given a couple minutes for people to make their way over. My name is Joe Betz. I work on SIG API Machinery as a technical lead. I've been doing that for a couple years. Before I worked on API Machinery, I also worked on as a maintainer of etcd for a couple years, so have a background in kind of both systems. So today's agenda is kind of an intro level session for API Machinery. So if you don't know what API Machinery is, we're going to spend some time going over that. Then we're going to go over the updates in the Kubernetes 1.33 release that we've been working on. And then we'll kind of finish out talking about some future plans and how to get involved in the SIG. So let's look at what API Machinery is. It's kind of a broad, cross-cutting SIG, so it's a lot of different responsibilities. Our core responsibility is the REST mechanics of the Kubernetes API. So that includes everything that is involved in defining a REST API, the versioning, the serialization protocols, resources, sub-resources, all of that. And at its core, like one of the main things we do is we provide support for building resource definitions. So that's how you build types, like the built-in types, pod, node, those types of things, but also how you build custom resources, so CRDs and things like that. Sometimes you'll hear the term KRM, which means Kubernetes a resource model. So we kind of have an opinionated approach to what a resource is, and a lot of that is supported by API Machinery. The various aspects of that include everything from defaulting to versioning to conversion, the semantics of apply and patch mechanics, sub-resources, all kinds of things like that. We have a significant amount of investment into control plane extensibility. So that includes, custom resources is one of the most prominent and obvious examples. But you can also add custom resources through aggregated API servers, so we support that. We support extensibility of the admission control. What that means is anytime a request is coming in, a write request is coming in to the control plane, you can intercept that through admission control. You can either reject it or modify it. And so we have two mechanisms for that. One is called webhooks, so admission webhooks. You can validate or mutate resources during admission. We also have a new form of admission control that is based on inline logic, so you don't have to write your own binary as a webhook. So we call those admission policies, and they use a small embedded programming language called the Common Expression Language, or CEL, to do that. We also support CEL more generally throughout the API. So that is a mechanism that we support that allows you to have small inline chunks of logic throughout the API. It's used in like DRA for expressing complex semantics if you want to allocate a resource. We're responsible for the language clients of the API server. So in particular, we spend a lot of time on the Go clients. But we support a variety of different clients. We have both typed and dynamic forms of those. So you can, the typed form, we provide one that provides all of the built-in APIs. You can generate your own typed clients, or you can use the dynamic client with CRDs. And we also provide discovery for clients, so clients can discover what's available in the API. We also provide the controller infrastructure. So the kube controller manager kind of as a framework is our responsibility. And more generally, controller managers are responsibility. So all the infrastructure to build those is things that we work on. So that includes the informer infrastructure, the watch mechanism, all of that to have efficient controllers running in your control planes. Beyond that, we take responsibility for the reliability, scale, and performance of most of the control plane. SIG scheduling does take responsibility for the scheduler specifically, but when it comes to the controller managers, the API server, a lot of that falls on us. We also share that with SIG etcd, which is an awesome new SIG that we have. To kind of give a sense of what the bounds of our responsibilities are, I figured it'd be helpful to talk about what API Machinery is not. So we are not responsible for API review. There is a dedicated group of really talented people that do that. So if you are working on a feature, you do need API review. We would be certainly happy to give you advice, but we are not official reviewers, and there's a dedicated group that you need to go to for that. We are also not responsible for all APIs. APIs are owned by the respective SIGs. So while we do own some APIs, we don't actually own that many APIs as a SIG. We own a couple around our extensibility mechanism. So the CRD resource itself is our responsibility, for example. We are also not responsible for controllers, although we own the controller infrastructure and the frameworking for controllers. The controllers themselves are also owned by their respective SIGs. We are not responsible for kubectl. That's owned by SIG CLI. And I've mentioned etcd a couple times already, but we are not directly responsible for etcd. That's owned by SIG etcd. And there's been a lot of good work on redefining the interface between machinery and SIG etcd recently. And I think that's benefited us both and has resulted in some opportunities to improve performance, which is great. All right, so that's kind of what SIG API Machinery is in broad terms. Hopefully this next section will make that a lot more concrete, because what we're going to do is we're going to go talk about individual KEPs that we've been working on recently. So this is the list of KEPs I'm going to kind of briefly go over. There's, I think, 9 KEPs here. They're broken up into things that are progressing or things that have been actively worked on in the last cycle. So there are other KEPs that are open in our SIG, but these are the ones that have had activity in the last cycle. So these are the ones I'm going to spend a couple minutes on each. So what I'm going to do is I'm just going to go through these in order, starting with the alphas. So order namespace deletion, this is a really great KEP for anybody that's had trouble with namespace lifecycle. It's just an alpha, so we want you to try this out if you're interested in it. Before this KEP was in place, if you deleted a namespace, there was no order of deletion of the resources in that namespace. So if you did happen to have some finalizers or some owner references, those would be respected during deletion. But other than that, it was just completely unordered. So the first ordering we're going to add is that we are going to delete the pods in the namespace and wait for those to stop before deleting the rest of the resources. This kind of eliminates that class of weird edge cases that you can have when the resources in the namespace impact the way the pods run, and if you're starting to delete them before the pods go away, the pods can kind of change at the last second and do weird things. So this makes for a lot more predictable performance of your workload. The next KEP is snapshotable API server cache. You don't have to read this whole thing. I'm just going to summarize it really briefly. For a long time, the API server has cached information that you can access from etcd. So not all requests to the API server go directly to etcd. A lot of them are served by a cache. That cache has been used heavily for watches for a long time, but only more recently have we started to serve more and more list requests from it. And this KEP finishes the story arc of making it so that all list requests are now served from that cache. It's restructured the cache and made it possible to do that. This is really important in terms of having predictable performance, because without this KEP, you basically have 2 code baths with very different performance profiles. And it's kind of hard to know, without being an expert of API machinery, which of those 2 code paths you were going to execute when you made a list request. So what this KEP does is it consolidates that all to a single efficient code path. So no matter what kind of list request you're making, you're going to get predictable performance. You don't really have to worry about it. Okay, next up is emulation version. This is a large change, and this KEP is actually filed under SIG architecture, but because there are a number of people in SIG API Machinery working on it, I figured I'd call it out. The way this KEP works is that we add a -- emulation version flag to binaries like the kube API server, and you can provide a version number, a Kubernetes version number as an argument. So for example, if you are running Kubernetes 132 binary and you set this to 131, that binary is going to pretend to be a previous version of that component. So it's going to basically, you can think of it as like it's automatically turning off APIs and switching feature gates to match the version that you asked for. So why would you want that? Well, one major use case for this is if you want to have more reliable upgrades, you can break your upgrade into 2 steps. First, you upgrade your binary version, but you fix your emulation version so that it's not changed. And so from a user perspective, the APIs and the features haven't changed at all, but you're getting to test out a new binary. So as a cluster administrator upgrading your cluster, you're testing out that new binary, making sure it works. And if it doesn't, you can roll it back knowing that you haven't accumulated any usage of new APIs and features because you haven't turned them on yet. So that's kind of the core idea. And you're going to see a couple other KEPs that we've been working on related to safe upgrades. This is another one of those. I'm not going to spend a lot of time on it, but the idea of mixed version proxy is that when you're upgrading, especially when you're upgrading a high availability cluster and you have multiple API servers, when you're upgrading, they're all not going to be the same version at the same time. You might have some that are 133 and some that are 132 because you're rolling your upgrades out. During that state, a user that is being load balanced into these API servers might be able to perceive the difference of those of whatever their request reaches, whatever API server their request reaches, because they're different, right? Some are adding new APIs, some are deleting old APIs that have been removed. So what this KEP does is it hides that difference. If your request reaches an API server that cannot serve the API you're asking for, it proxies it over to a peer that can, if one exists. Next up is the CBOR serializer. So we've had CRDs in Kubernetes for a long time. CRDs are served and stored as JSON today. That's not particularly efficient. So CBOR is a binary protocol that is basically JSON equivalent. It is a self-describing protocol, but it doesn't have the serialization and deserialization cost of JSON. And so we're going to be using this in storage and when clients ask for it over the API to get a far better kind of performance profile of serialization, deserialization. It's pretty cheap to use. So you don't get quite the storage compaction you do of protobuf, which is what we use heavily for native types, but you get something that is quite a bit closer. So this will be a big improvement performance for CRDs. Next, we're into our betas. So the first beta is declarative validation. This is not something you are going to see as a user directly yet, but it's a big change to the way that we're developing Kubernetes. The idea is for, as long as the project has existed, we have defined our APIs in Go structs and then written a bunch of handwritten validation in another file next to it that controls what's allowed to be written to those fields. And so if you actually want to know for sure how a type in Kubernetes is validated, the only real way to know is to go find those Go files and hunt through and look for the validation code. So what we're going to do is we're going to replace all that handwritten validation code with markers on the Go tags that declaratively specify what the validation is. This makes it a lot easier as a user to know for sure what the validation expectations are. And then it also allows us to build tooling based on this. So today, if you go to our open API schemas, which define our types, you're not going to find a lot of validation information. But once this is in place, we can then publish this information out through OpenAPI, and you'll get a far more enriched validation summary from that endpoint. We're going to be generating the internal validation code from these annotations, so they are going to be the source of truth. They're going to be, if you see one of these, you know that that's actually the validation rule. Next up, the next beta feature is coordinated leader election. This is a kind of complicated topic, but the basic idea is when you're running an HA cluster, you're going to be running multiple control plane nodes. And each of those control plane nodes has a controller manager, the kube controller manager running. But the way that we want to run the kube controller manager is we only want one of them active at a time. We want mutual exclusion. And so the way that we've achieved that today is that if you have 3 of these controller managers running, they race for a lease. And the one that wins that lease becomes the leader, and the other 2 become passive backups or passive replicas ready to take over at any time. So we're going to change this slightly because this works really well during steady state when those controller managers are exactly the same. It doesn't really matter which one wins the lease. But during an upgrade, you can perceive the difference depending on if the old version or the new version gets the lease. And during an upgrade, it's really easy to have a situation where you start with the old version, go to the new version, jump back to the old version again. And that can result in kind of surprising behavior depending on what's going on. So what we're going to do is we're going to switch to a slightly different approach of leader election, where all of the controller managers announce their candidacy for the leadership. And then there is a centralized leader election coordinator that looks at the candidates and picks the best one. The default strategy for now is going to be pick the oldest version, because that keeps you from violating skew between components, both for upgrades and for rollbacks. But we are entertaining other strategies, and this can be used more broadly. You can use this to actually ask the current leader to give up leadership, which is not something that you can do today. And you could have different strategies for different systems. Next up for betas is streaming encoded for list responses. This is probably the most significant performance enhancement in this release, and in fact in the last couple of releases. So what this does is it switches the way that we serve list responses back to clients from accumulating all the information in memory when serializing and then sending it after we accumulated it, to sending to serializing each list item one at a time, streaming it back to the client, and not maintaining any more memory than that in the API server. So you can imagine if you are requesting a list response for hundreds of thousands of resources, the memory profile of the API server is dramatically better in this. It can concurrently handle many, many large list requests without running out of memory or running into problems. So this is a huge stability improvement for the API server. I'm really looking forward to it. The last KEP is CRD validation ratcheting. This is also kind of a subtle feature. So today, when we validate resources, either if it's a crate or an update, we just validate every single field in the request. It seems like kind of an obvious thing to do. But for updates, if a field hasn't changed, you don't actually need to revalidate it. You already validated it when it was created. And so ratcheting is the idea of not doing that revalidation. And the only reason that this actually becomes a perceivable difference is sometimes that we change the validation on fields. So this happened in 133. There was a CVE around IPs and CIDRs, and we introduced tightening validation for both of those types. And what that means is that previously valid stored field data has become invalid. And so now we have two choices. We can either reject all updates now that that tightening has happened if the old data was bad, or we could choose to only reject updates that actually touch those fields. And we've chosen the latter, that we believe that it's a much better transition experience if you're tightening validation to only fail if you're actually touching the fields you're in, that have the validations changed for. So we added this to CRDs a while ago, and we're finally bringing that to GA. So if you have a CRD and for some reason you need to change the validation, all your controllers that don't touch that field should continue to work. It's only your clients and controllers that actually interact with that field that might start breaking, which reduces the risk of the change somewhat. It's still a breaking change. It's still pretty dangerous, but sometimes you have to do it. All right, so that covers, I think, most of the KEPs. Let's talk a little bit about future plans for SIG API Machinery. So there's two areas I wanted to point out. The first is you probably noticed that we had quite a few KEPs coming in around making upgrades safer. This is a priority for our SIG. As Kubernetes matures, we want to make sure that we make upgrades the best experience we can for users. And it's going to take us a while, right? Like we need to earn trust with cluster administrators. But by adding some of the KEPs that we've added, we're providing the tool set to make those upgrades safer. And that combines well with other things that are happening at large in the project. So for example, other people outside of SIG API Machinery, like Jordan Liggett, have been working hard to improve our backport policy so we don't break patch versions by backporting things that are risky. So we've really done a lot of work to make that safer. We've also stopped turning on beta APIs by default because eventually those all go away, and that's a breaking change. So now if you're not actively turning on beta APIs, you're not going to be broken by that. So that's kind of the trend that I hope people can see here. The next kind of significant trend is in towards declarative APIs. So there's kind of two aspects to this. There's declarative validation, like I mentioned, is focusing on making built-in types more declarative, improving their defaulting, improving their ratcheting, things like that. We're also focusing a lot on bringing CRDs more in line with how native types work. Now, CRDs are sometimes ahead of native types. CRDs have had declarative validation for a long time, and that's worked out pretty well. But they're also behind in some areas. So just in the last release, we finally added field selectors to CRDs, and that's a really useful feature. You can now filter CRDs by some field in them. You can use that in, along with some of the new authorization features to do useful things, like constraining exactly what resources in a group of resources a particular user can see. And so there's more KEPs coming along like that. Additional printer columns with cell is going to allow CRD authors to give a very specific view of their CRD when you ask for like a table format back in kubectl, which has been missing for a long time. We're working to add more validation formats to CRDs, so you can do things like say, I want this to make sure the CRD's name or this field here is a Kubernetes resource name. It's a valid Kubernetes resource name. Today, the only way you could actually do that would be to go find the regex and plug it in. So we're going to give you a named format for things like that and a bunch of other things. There's also gaps in the way that you can compose types. So if you're trying to embed a type in another type, or you're trying to reference another type, there's not a lot of API machinery support for that. So we're looking into ways to do that better. All right, that covers most of what I had to present. The last thing I was going to say is we are actively looking for contributors in the SIG. If you want to reach out to us, here's our Slack. We meet twice a week. Sorry, I gave US times here, but hopefully these are somewhat European-friendly times. And then I've listed out our chairs and leads. So with that, I'm going to stop and take any questions you have. Thank you. We'll use this one.
I was looking to, can you share some more details about the new formats that you're going to provide for the API? Like label selectors is an area where I don't want to use a webhook to validate it, so it would be nice to have it included in the API spec somehow.
I will add to these slides and upload it. We have an issue that is tracking requested formats and improvements. So I think label selectors was already on there, fortunately. But yes, there's a variety of other ones, including like I think we support like an IPv4 and IPv6 format, but we don't support a general IP format that could be either. So there's a bunch of like really core types that are missing, but also things like selectors and conditions and status and things like that. All right. Oh, yeah.
Anyone else? I'm seeing that there are some issues that, for instance, server-side apply defines some list types and merge keys. While in Customize, you have the patch type and patch key, I think it's called. It's very similar and kind of represent the same thing. I went to another talk around with SIG CLI. I was wondering who could put that forward. I work as a platform engineer, so we do a lot of CRDs and we provide CRDs to our users. And they also use tools like Customize. Not the CLI tool, but in other contexts like Flux or Argo. And I would really love those things to be coordinated, so we don't have to provide extra tools to support customize better.
Yeah, I would love to learn more about the specific problems you run into. So if you have an issue, please send it out to the SIG. But yes, there are 2 patch mechanisms that have almost identical requirements in the metadata that you need to put in the types. My intuition is that could probably be made better, so we should look into it. All right, any other questions?
How's the journey? That's loud. How's the journey from original streaming support to maybe something more modern that's like quick and HTTP3 fully standards compliant? How's that going?
So is this a question about the JSON streaming support or?
The HTTP layer.
Yeah, so the streaming support we've done in this release, I don't know if this answers your question, but I'll try, is mostly focused on making sure that the API server doesn't accumulate a huge response in memory before it starts serving it. So it's mostly focused on that aspect of it.
So I'll clarify. I was talking more about like if I'm going to do a streaming request to fetch. I'm going to exec into a pod, and that's a streaming thing, but the API server gets involved. So that sort of evolution from early Kubernetes to where we want to be.
I think once you have the streaming responses we have on the list today, plus the watch mechanism, once you've got that initial list done and you're starting the watch, you end up in a pretty efficient mode where you're just kind of constantly getting updates. Is there a performance problem, or is there kind of a standards question? Is it more of a performance question or more of a standards question?
I was asking about the journey towards like web standards. So for example, WebSockets over HTTP3 as something that any client that understands how to do WebSockets could use for an exec. I know that's a Node API, but as an example.
Oh, yeah. We did recently, I didn't list it, we did recently do work to move away. So we have moved over to a standard WebSockets, and we're using, I think, the Gorilla library for that. So there is a KEP for that. I believe all the code merged this release. So go check that out and see if that handles it. All right, one more, and I think, yeah, there's one back there.
I had a task recently to introduce a new API field that needs to be synced with already field in the API. So what is the approach for read requests to default this new field? Because of the defaulting and validation, they are concerned only for write requests.
So are you asking to add a new field to the standard APIs?
Not the standard API, but to API server extension in our case.
Yeah, so you can add declarative defaulting today. We just merged declarative validation in 131, and we've only added a couple validators so far. So it's a little too early for general purpose use in aggregated API servers, but it's just another generator. It's validation gen right next to defaulter gen and default gen. So as we build that out and add more support, that'll very quickly become available. So over the next couple of releases, keep a very close eye on that. And if there's specific validators you need, please reach out.
Yeah, it was more or less like we already had a field, and now we introduced for the service IP and IPs that was introduced a couple of years ago. And when you introduce this new field, you have to keep it in sync with the already existing field for compatibility reasons.
I'm sorry, I'm not sure I totally followed that.
You know, in the service API,
right?
Yeah, spec IP was a singular IP, and when the IPv6 support was added, then this turned into an array, not a single value.
Right.
And both this field had to be kept in sync. So when you send out a create or update request to the API server, it can sync them with the defaulting. But if you just try to read a service, then basically there is, I I think, no defaulting, and you, as a client, you might not receive the new API resource with both fields set.
Yeah, so is your question, are we working on that, or?
Yeah. If there is some approach to...
We should talk to the experts on that. I haven't touched that field in a long time. Yeah, so bring up an issue or drop something in Slack. There's a couple experts that we could talk to about that one in particular.
Thanks.
Yeah, thank you. All right, we're at time. Thank you so much, everyone.